later. So nice to meet you all here and have the pleasure to present to you how we do automated deployments for our feature branches. So, hi everybody. I'd like to start with a quote that I made up, but I can pretend that it actually is true. So, it requires more courage to deploy than to die, says bad DevOps Napoleon Bonaparte. And who here is happy with their deployment process? Raise your hands. Wow, 3 people, 4 people maybe. That's so many. I know how you feel. I've been there, and it has been horrible, but there's a silver lining on the horizon. So what I want to talk about is a campaign to basically fix deployments, or actually give you inspiration. I'm not going to give you a solution. I'm going to give you a solution, but it's a solution that you definitely have to adapt to your own needs. And please help me on improving the solution, and actually tell me if you find a variation of that. So I want to give you building blocks to actually make that happen. So I'm Martin. I'm living in Zurich, Switzerland. I'm working for a company called Archeologic, and we are a small team working on web technology, but we have various interesting things on the back end going on as well. So we have a few components, and we want to iterate quickly, and we want to deploy those. So what I wanted when I was tasked to fix our deployments is I want everyone on the team, and today I want you all to deploy whenever you have something to show. Don't fear, just you shall have a playground, you shall have an environment where you can change things around and then actually show it to others and collaborate and get feedback really quickly. And that requires deploying as often as possible, because obviously, yes, every developer can check out the updated code, but the more important and more interesting opinions are not from other developers, but actually from users or from team members who are non-technical team members. So to get those on board, you have to deploy it somewhere for them to actually use this. And this is basically what it boils down to. So what we do is we create new branches from whatever is considered stable and shippable right now. We do batshit crazy things about it. We try out various things. Virtual reality, we tried out virtual reality in the browser. You can't really ship that immediately because you've got to really, really carefully test that stuff. And then you just commit it into your branch, and it doesn't actually collide with anything that gets shipped. And then you push it into your blessed repository, and hopefully a build server picks it up, actually tests if it runs, and then it's deployable, and it gets deployed automatically without you having to interfere with it. And then people can try that out. Sweet. So if that works, we're going to high five. So this is what we're going to look at today. So our example application is going to be a Sinatra application, just because I'm lazy and I wanted a really small application with not so many dependencies. We're going to use Jenkins as the CI server. We're going to use Docker to basically build up a deployable artifact. Then we're going to use etcd and confd, and we're going to cover these in a bit more detail. And we use nginx just for back proxying or reverse proxying. So you can use a few other technologies as well. So most importantly, what you do here, I don't care. And my solution doesn't care either. You can use Node.js, you can use Go, you can use Java, whatever floats your boat. I'm fine with that. Rust. So looking at so many technologies might feel a bit overcrowded and complicated. So I'd like to somehow give it a bit of flow. So our code is being checked in. Jenkins is going to pick it up, run tests, set up databases, whatever, then creates a Docker image, and then somehow also announces this server to etcd. So that's basically service discovery. So this etcd here just is there so that we know what kind of deployed feature branches we actually have. And then confd is used to get that into nginx. And then nginx proxies from the outside into the Docker containers. Okay. So that looks more like this. And hopefully it works like that. So here's our Jenkins job. So Jenkins does basically 2 major tasks. One is actually creation of the containers and making sure that we have a container that we can run. It also removes containers that are no longer used. And then runs tests, set up databases, seeds databases, whatever you wish. It's all optional, but I'd say it makes sense to use a CI server to run tests. And then it runs a bit of shell script. So in this shell script here, we're going to get the branch that we're on right now. We remove the thing up to the slash because we're going to get something like origin/master. We only care about master, actually. So or origin/my feature branch. So we only care about my feature branch. So that's what this line does. and then we're just going to output what branch we're actually looking at, and then we use a tool called go deploy, give it a path, which is this current working directory, give it an application name, and then the branch name that we're going to build on. So go deploy is basically taking care of this, right? So go deploy, what it does is it builds our containers, it removes previous running containers and images, and then announces them to etcd or etcd so that you actually can discover them. So what exactly is it doing? Well, first of all, this URL does not exist yet. I'm going to push to it after the talk. So you're the first to actually get your hands onto this. Please submit pull requests. Please complain in the issues. Please help me make this tool great for you as well. It works for us. It might not work for you. Let's try to fix that for you then. What it does is it's a small Go program that checks if a container for this particular application and branch already exists. If so, it cuts it down, it removes it, and it also clears out the image and builds a new image from that. And then it just advertises it to etcd so that it can be found. etcd on its own is very, very useful if you want to store configuration or anything really. It's basically a distributed key value store. It has a really, really simple HTTP API, so no big deal on actually querying that one or manipulating that one. It's simple to install because it's a binary and it's shipping from all major architectures, so you don't even have to build it. It's hilarious. There has been an issue that asks for how the hell do I install it? Because you're so used to running npm install and then, okay, I don't have the right version of Node, so I'm going to install the right version of Node. Oh, I need this library. And then you get into this entire horrible thing. That's not the case here. You just download the binary, you put it into your path, that's it. That's all you need to do to install etcd on your computer or on a server. And it comes with a utility called etcd-ctl so that you can easily use the command line to query what's going on in your key value store. And it's going to look like this. So here we have two apps, app 1 and app 2. We are only having one app right now, really, but it could change in the future. And actually, no, we're having two. Never mind. And then you can have branches for each of these apps. And it's going to store. So this is the value, the key that we're having. And the key tells you, so app 1, branch 1, tells you where the container lives. Which container is it that runs this particular version? And it's an IP address. It's an internal IP address, so it's not reachable from the outside world. But it's an IP address that we're going to use to give to our Nginx to sort of let requests through. No one has to know these IP addresses. I have no idea what IP addresses our branches live on. That's the good thing. Right. And now we are here. So we have built the container using a go deploy, and we have announced our container into etcd. Now we need more steps. The easiest thing to do that is using confd. Confd, again, is a Go utility, same simple installation process. You download the binary for your application platform, for your server platform. You drop it into your path. You're done. It connects to etcd, and you configure it in a way that it tells what keys to watch on etcd and what files to write from it and how to write these files. So all it does is it watches etcd. If something in etcd changes where it watches, it then takes this information and puts it into configuration files. And you configure which configuration files and how these configuration files are going to look like. And it then also can reload and restart processes. So for us, we're going to reload Nginx every single time. We're going to change the configuration so that new branches become available. All right. So this is how a config looks like. Here we're basically saying we have a template file, which is feature-branches-conf tmpl, which is a file that lives somewhere on our server, and that contains how the output should look like whenever something happens. And then we say, please write it to etc nginx sites enable default conf, and please check all the keys below /deployments. And whenever you are having a change that you actually have written out, then please reload by using service nginx reload. So here you can configure whatever service you have to restart. Here you can configure the prefix that it should look at. Here you can configure which configuration files it should rewrite. And here's the template that it uses to do this rewrite. All right. So now how does this template look like then? I left out bits and pieces. Obviously, you have to sort of make sure that it serves on a certain port and I don't care, this is never going to change. But what's going to change is we're going to reverse proxy. And we're going to reverse proxy /app1/master, for instance. So the key is the /app1/ master slash app1 slash my branch, and so on and so far. And we basically, when I go to featurebranches.mycompany.com slash app1 slash master, I want to actually see the running version of that. And to do that, we pass that request to the value, which, if you remember, is the IP address of the of the Docker container that actually runs that. It's a Sinatra application, so I couldn't be bothered. You could save more information into the etcd, but I just have the IP address, and then the port is always the same, so that's kind of fine. And so what happens is when I go to slash app1 slash my branch, it goes here to slash app1 slash my branch, and those proxy pass that to the IP address of the Docker container that's actually running my application. Nice. So this looks more or less like this now. That's a lot cleaner. So here are our containers. This is app1, branch1, and so far. And this is go deploy, and this is Jenkins triggering go deploy, as we've seen as a bash script step. Here's etcd, informing confd, and then that all goes into nginx, that then proxies the requests. Not too bad. I'm not going to live demo. Actually, we can try to live demo. If the live demo fails because of internet, then I got to fall back. There's my terminal. Oh, it pretends to not be in the, you're lying to me. Yeah, that looks more like it. Can you read this? All right, that's beautiful. So I'm gonna, because I can't remember the, screw that, I'm not gonna do it here because it's gonna download things. So I'm going onto one of my servers, and I hope that works. Okay, Internet Probe 3, 2, oh look, okay, it kind of works. So here, I have never ran any container. I have one base image, which is the Alpine Ruby image. I could delete that and it would re-download it, but that's my base image that I'm going to base my containers on. And then I can ask etcd. Etcd is empty at this point. Okay? We can also have a look at nginx sites enable default. So here is the rest of the configuration file. It just sets up a server on port 80. It listens also on IP version 6. It has a standard index file, and it has a server name of localhost. That's not terrifically interesting. So now, where's my browser? I could go to, yes, I think that's the one, to Jenkins. My Jenkins is empty as well. Okay, fine. So depending on how fast this is going to go. So I'm now creating my project in Jenkins that actually checks out a repository and makes sure that, oh boy, conference internet, huh? It's not too bad. I can switch at any point in time. So I'm going to call it Topconf app. Say OK. Ugh. Really? Right. Come on. If you get bored, just show your hands, and I'm just going to switch over to the video, and we get over with this. Right. OK. You know what? Video time. I can't be bothered. I get bored with this. So let's not do that. So here I'm doing the same steps. I'm checking if we have ran any containers so far. No, we haven't. So over to Jenkins, which, yes. Creating a new job. It's a freestyle project, as there's nothing specific about this one. I'm going to use Git. You can use whatever you want to use. You can use Mercurial, CVS, Subversion, or please don't use like zip files and emails. That's not supported by Jenkins, and I don't think they're ever going to do that. We're going to watch for all the branches. So every branch that gets pushed will get actually triggered here. And we pull the source code control. We're going to pull Git every minute. And here now comes the, the shell step. It's the shell script that we've seen in the, oh boy, it's probably because the video is also too large here, isn't it? However that works. Damn it. All right, better. So now I'm in the, that's a bit too fast for me as well. So now we're in the repository. I commit all of these changes. So it's a simple Sinatra application with a SQLite database. You can use, obviously, other database systems and actually have them, for instance, run on your host computer or run them in separate Docker containers, whatever you wish. I'm pushing to the server. So I wasn't sure if the internet is good, and I only noticed that I should actually record this yesterday evening, so it's total Wi-Fi already, but it's still pretty okay. So here we see that it has triggered. There is a new build being triggered. I don't know why Jenkins does this question mark thing, so okay. And now we can see what happens inside the build. So here you see it's getting origin master, so we're building master. And now go deploy runs. It removes previous containers. There were none. It builds the new image. So that downloads a few things from the internet. Then once it's finished, it says creating container. It created a container with a certain ID for us to debug later on if we wish. And the container runs at this IP address. Cool. So now we can check how our Nginx configuration looks like. And it looks like this. So here, we now have /deployment /app1/master. And it takes a little moment. That is the index page, so I mistyped something. Oh, I didn't even type it in. Brilliant. And I typed in the correct IP, and there we go. There's our application. It's a very simple application that allows me to enter some random books with an author and a title. And then, why did I pick that title yesterday evening? There we go. It's saved into the database. Now we can run a second one. Yeah, sweet. So we're done here. I have a running application. We can check that out. I can give that to my project lead or to an external customer to play around with it and tell me if that's what they wanted. But how about we check out a different branch or create a new branch? So now we created a branch called films, which indicates that we just want to try something out. So we changed the template and now it's a very simple change. We just remove the headline books and substitute with films. Very, very crazy change, very dangerous. Not sure if that's going to work. So why not films? And we pushed that one. Yeah. Getting pushy. So now, if we go back to Jenkins and go back to the project, and I had to cut it off a bit because the Wi-Fi was horrible at that point. So number 2, it's building. I didn't have to click anything. It did that automatically. So again, it builds the branch. It created a it creates a container. It runs the container at some specific point. And I can now change that for films, and there we go. We now have both branches running and online. So that's quite cool. Okay. That's an interesting behavior. By the way, where did my taskbar go? Okay, it goes onto this screen now. Brilliant. Oh, Jesus Christ, this is weird. Clicky. I'm doing really well on time. I'm not sure why I rushed that much. So, oh yeah, here's a YouTube version of that, if you ever have Wi-Fi. So that's pretty cool. And the interesting thing about this one is, so this Go script that's behind that, that's this small piece of glue, really, is a mere 100 lines, and there's a lot of logging going on there. So with a couple of lines, you can even write it in Bash. The original version has been in Bash. The problem is that wasn't very maintainable because it was not very readable, but it totally worked. We had another version, another iteration, because we have some Python scripts in our stack. So we used Python just because we didn't want to introduce a new thing. But then again, Python scripts are a bit unwieldy sometimes, especially when you deploy on EC2 machines where you might not have Python installed, so you would have to install Python, and we're like, nah, just have a binary that we can easily drop. And all these pieces are basically interchangeable. You could throw away this Go deploy script and write your own, relatively simple. The Go script, basically the script in the repository that you can use, is more or less a template for you to write whatever you need, because the basic principle is relatively simple. And you can change the app stack. Because if you think about it, neither the Jenkins job, nor the Go deployment script, nor anything actually relied on what stack we are using. You build this Docker you build the Docker container with a Docker file that obviously depends a bit on your stack. But from that point on, I don't care. We could easily swap that out with Node.js by just replacing the Docker file to actually start from the Node.js base image and then install all necessary things. And the rest of the pipeline would stay the same. The source code management system doesn't matter. This one uses Git, but the only thing where it actually mattered was in the Jenkins configuration. So if you have a working Mercurial, you go ahead, use that. As long as you get a branch name of sorts, I don't care. You can even entirely throw away the source code management, which is a bad idea. But if you wish, you can do that because you can have a parametralized build where you have two things, which is one is the app name, the other one is the branch name, and you enter that manually. Fine, pay an intern to do that. You're creating jobs then. The CI server, it doesn't really matter if it's Team City or if it's Go Build or what it was. There's a few other things as well. If you use mission control, cruise control, whatever, just go with it. You just have to create this job that basically fires off a shell script. Or you scratch that entirely and run a cron job every 5 minutes. Fine by me, I don't care. It works, it will work. The reverse proxy, that's just convenient so that we don't have to know the port numbers on the host system. So you can use Nginx, you can use Apache too. We're actually not using Nginx, I just use it because the configuration is simpler. You can use HA proxy, you can use Gatling, whatever, just any servlet container if you so wish. You can actually also entirely ditch Docker and reverse proxy and just deploy into a servlet container and then use Tomcat or Glassfish or whatever you're going to use and basically just announce the paths and ports so that it actually is available as well, works as well. You can also throw away confd because theoretically it just watches and reads from etcd and then puts back into the, or gets read rewrites the configuration based on that. If you don't need that, if you write your own bash script that reads from, I don't know, a MySQL database and rewrites configuration based on that, sure, go ahead. So it's pretty modular, actually. And some adaptations, if you don't want to use Docker, obviously Go deploy doesn't make sense because it relies on Docker and etcd. Etcd is also not so easy because, again, Docker, Go deploy relies on Docker and etcd. So if you want to change these two, just throw away my little Go program and write your own. It's not so hard. The benefits are pretty obvious. By using Docker, we're having repeatable builds and repeatable deployments because we have this container image that's never going to change. And these images are not so large if you do it right. So if I have, and actually that happened, so we had a problem that only manifested inside the Docker container for whatever reason. I can't remember what was the problem. I downloaded the image onto my local machine. I installed a virtual box that had Docker inside because I was on a MacBook at that time. I created a container running from that image and I debugged it. No problem, because it's pretty universal and it's pretty portable. Another thing is once you've done that, so this is cool and nice and fine for feature branches and your development work on day-to-day basis. But what about actually deploying? So for instance, right now we are relying on Heroku to deploy. And we asked ourselves the question, what happens if Heroku goes down? And we didn't really have that good option, like, well, we could try to sort of bring it all up on AWS, but that might take a little while. And we tried, and it took us like an hour or so to get everything together. But then again, there's Google Cloud Engine, there's AWS Container Stack, I think. I'm not sure how they call it. They have the possibility to drop in a Docker image and then create containers from it. So with that, now, when Heroku dies and goes down, we basically pull our image from the development server or from the feature branch server, throw it into, we actually tried that. We throw it into AWS or Google Cloud Engine, and we are running again. And we can do that with any branch, which is really cool. So you're portable. You can also move. And basically, you have the same artifact that you can use on local machines as well as in production, which is quite handy. It's also isolated, so each application doesn't have to worry if it's actually colliding with other tables or if it's colliding with other resources, because they are wrapped in this small world and they think they have this much resources available, but actually you have more resources available, but you can limit it down. You can link it with other containers. You can give environment variables into that, so you can configure these containers on runtime as well. Really powerful. Even better, you can also hook it up to etcd and actually have your configuration come at runtime or at startup time from outside into the container. That's all possible. And I think the portability bit is the biggest benefit, really. Oh wow, I'm already through the live demo would have taken longer if I wouldn't have recorded it, because it downloads a bunch of stuff. So we're having a lot of time for questions, I think, and I'm gonna go ahead and push to GitHub right now. Thank you very much for your attention. Any questions? Yes.
Have you considered other service discovery?
Like Zookeeper. Consul. Yes, we have considered them. So the thing is, Consul is quite awesome because it uses DNS. That's cool. I think that's really cool. But back at the time, so this has been running in production as far as there is a production that does this. For a year now, and we haven't changed that much, because back then Consul was a bit earlier on and I had some troubles, I think, setting it up, so I went for etcd, which had 0 troubles and 0 overhead. That might be reconsiderable for Consul, for instance. Zookeeper works as well, but Conft had some problems with Zookeeper back at the time. I think now they have a proper provider that works with Zookeeper. Does that, there's no technical reasons, it's just etcd came, did the thing that I wanted, was simple, 0 configuration, hey! So that's the only reason. Why would you use, or what would you use, and why? Ah, right. So why is that? Why Consul? There must be a reason for it then. I see, okay. Yeah, if you need DNS, then that's perfectly fine, right? If we don't really, I don't care about DNS that much. I have a coworker who's really into it and keeps bugging me like, change that for Consul. I'm like, do that. I'm not gonna touch it. And then he's like, oh, I have other things to do. I'm like, yeah, see, told you. Other questions? I should have repeated the question. The question was why etcd and not one of the other service discoveries. Reason, there's no hard reason, it's just, it came, it went, it came, it saw, it won, to paraphrase Caesar. Yes?
Have you used etcd before? Or
yes. Okay. So we used it as a configuration service beforehand, so a central configuration store. So you already knew it? We already knew it, we already had it installed, so okay. It just happened to be useful for this other purpose as well, so I'm like, yeah, let's stick with it.
There is a nice Docker image called Nginx proxy that does kind of the same thing as a Docker gen inside, and it watches the containers coming up and then regenerates the Nginx configuration and reloads the Nginx server, so you don't need the conf and
yeah, that's true. That's true. We just happened. So Jeff Lindsay, basically the moment we had it working and we were happy and confident, Jeff Lindsay, he's the guy behind Doku and called Progium on Twitter and GitHub. He posted a Docker script thingy that has like Docker events or something, and that then led to things like all the other cool things. I think you can even do it with Kubernetes these days, and there's tons of solutions out there. This is just one. So all these solutions are quite not really large. The Nginx proxy one is a particularly nice one because it's just a Docker container, really. But most of the solutions are kind of come as an ecosystem, whereas I prefer to have small parts that I can glue together to then actually have a solution that if something doesn't fit, or if something turns out to not suit us for another changed requirement in business requirements or technical requirements, we can basically tear it out and put in another thing. Make your own choice, obviously, but I highly recommend this one. Any other questions? Yes?
How will you use this if you have a microservice architecture with different services?
Well, then this isn't really for large deployments like that. So if you have a microservice architecture, you probably want to look at something like Fleet or Kubernetes, because these allow you to basically have dependencies, and then you can say, hey, my system or this particular branch requires database version 5, web server version 6, and I don't know, magical queue management system version 12. And then it actually makes sure that these are powered up and linked together so that they have environment variables that it can rely on. So this is not particularly for very large components or very large deployments of components. This is literally, I have one thing that has this 1 or 2 containers, and I sort of want to deploy it all over. And a lot of people, the reason why I talk about this right now is when we had this idea, we're like, how do we actually make this happen? And I was like, well, Docker, okay, cool. So we wrote a thing, or basically our bash script that was inside the Jenkins job, then created all the Docker components and stuff, but then it's like, okay, how do we link them? And how do we actually remove those that are no longer needed? So that was a bit trickier. So I thought, if I hit that roadblock, other people might hit it as well. You might hit another roadblock after that with a microservice deployment. Sorry. Further questions? Wow, I think we're done then, and we're early on. How much time do I actually have left? Because in the other talk I was running over, and now I'm, what?
10 minutes.
10 minutes. Okay, that's an extended coffee break. Come find me if you have further questions or suggestions. Actually, you can watch me suffer now that I try to push something to GitHub. You profit, I suffer. All right. At origin get at github.com. AVGP go deploy .git push origin master. Oh, hey, that actually doesn't look too bad. Oh, I jinxed it. Still better than China. Hey! Yeah, there we go. And this is all it does. It's not that dramatic. Oops. Oh, this is the executable. So if you're running 64-bit Linux, then you can just use the executable from here. It's actually, how large is it really? Doesn't say, huh? Does it? Yeah, 8.6 megabyte. Why is it so large? I should probably strip down a bit. Anyway, this is how it looks from the inside. So the main thing takes the arguments, creates an image name from the arguments, has an endpoint, which is the Docker API, creates a new Docker client. Then it says remove container and image, build image, create and start container, announce container, and then we're done. And each of these functions is basically more or less a small-ish wrapper. So here we have the configuration, which is just the image. We say create container from the image. And if it fails, then I cry. If it doesn't, then I try to start it. If it started, then it says yay, and then we get the IP address of that one. And then we only have to run, build image is actually building the image. This one creates the container. Where's announce? Announce is, I can't, yeah, there we go. Announce is rather simple. Here you see how the etcd API looks like. You have an HTTP client, you have a base URL, you have the app name / the branch name. Then you say put onto this base URL / app name / branch name. Strings new reader from content. Content is value equals and then the IP address. Make it an XWW form URL encoded. Give it the content length, you're done. Easy API. So yeah, thanks a lot. Enjoy the conference.